All right, cool. Well, let's get started. Welcome to Build. Welcome to the Windows Bridge for iOS session. Really excited you guys are here. I'm excited to be here. It's my first build, actually. So this is really cool for me to be here talking to you guys about the iOS Bridge. So, what is the Windows Bridge for iOS? Well, my name is Nick. I'm a program manager on the iOS Bridge team. And as I said, this is my first build. I'm actually pretty new to Microsoft. I just joined the company in the fall. And before I came to Microsoft, I was an iOS developer. Now, quick show of hands. How many people here have at least dabbled in iOS development? That's good. You guys are in the right place. So this is a Microsoft conference, so a lot of the people here are C# developers. But for you guys and for all the people watching the recorded session later on, there are a lot of iOS developers out there. And if you're an iOS developer, you've invested a ton of time and energy, not to mention your own blood, sweat, and tears, into learning not just the ins and outs of Xcode, but Apple's whole set of tools, right? You've learned how to use storyboards and auto layout to arrange your UIs. You've learned how to use UIKit to build those UIs. You've learned how to use Core Foundation and Core Graphics and all of Apple's other frameworks to build your app logic. So we thought, wouldn't it be really cool if there were a way for you to take not just that code that you already have, but all those skills and all that experience that you already have developing for iOS and leverage those, put those to work building UWP apps. So that's exactly what we've done with the iOS Bridge. The iOS Bridge is an open source SDK that allows Objective-C developers to reuse their existing iOS code base to build UWP apps. Now, how do we do that? We do that by adding rich Objective-C support to Visual Studio and UWP. Now, what do I mean by rich Objective-C support? Well, we could take your iOS app and stick it in a box and throw a skin on it and call it a UWP app, right? But that's actually a really bad experience for not just your users, because they're using an app that was really designed for another platform. But it's also a bad experience for you as a developer, because you wouldn't get to take advantage of all the really cool stuff that Windows has to offer. So we've designed the iOS Bridge to fully embrace Objective-C on Windows. That means you get to use Windows Runtime APIs, the full set of UWP APIs, directly from Objective-C, using the language you're already comfortable with, using the skills you already have. But it's not just the Windows APIs, right? Because if you've made an iOS app, you're taking advantage of all those frameworks and APIs that Apple has built for you. I mentioned a few. I mentioned Core Foundation. I mentioned UIKit. But there are dozens and dozens more. There's Core Graphics and Core Image and all that other stuff you're already using. So to make this really work, what we've done is taken large parts of those frameworks and implemented them on Windows. So large parts of your existing code base will just work. And you can build a UWP app using both Windows APIs and iOS APIs. Now, you'll notice that I said parts of those iOS frameworks. And I said that for a reason, because iOS is really big. There are dozens and dozens of those frameworks, and each one has hundreds and hundreds of classes, and each one of those classes has hundreds and hundreds of methods and properties, etc. So it would be impossible for us to cover the entire thing. So this is not a write once, run everywhere solution. The idea is to quickly get you up and running on UWP, to get you quickly to the last mile of development, so that you can then embrace all of the features that Windows has and create a really great UWP experience. Now, there's some caveats to that approach, right? Because iOS is big, we're not going to cover every single API, every single framework, every single method that you're already using in your code. Some of them won't be there. So the last piece of this is not only have we designed it to be easy to use, to quickly get up and running, but we've designed it to be easy to extend. So if there's a piece that you're using that our team hasn't built yet, you can build it yourself. And because we're open source, you can contribute it back to the community, and the whole project grows. So I want to pause on that open source bit for a second, because it's really important to us. I mean, open source is increasingly important to Microsoft as a whole, but it's really important to us as a team, because it's not just something that we do for street cred with the developer community on GitHub. It's really absolutely fundamental to this goal of maximizing your code reuse. So we open sourced last August. We released the bridge on GitHub, and we're really happy with the response that we've gotten so far. We've had a really engaged developer community around the project. We've had people filing issues and pull requests. We've accepted a lot of those pull requests. And the issues really are the best way to get in touch with our team. We push out a new release to GitHub every week, and it really guides our development. So that's what the bridge is. Let's talk a little bit about how it works. The way I think about it, the bridge breaks down into 3 chunks. And the first chunk is our Objective-C compiler and runtime. So if you're an iOS developer, you might know that Apple uses the Clang compiler frontend and the LLVM compiler backend. But Visual Studio uses the C1 compiler frontend and the C2 compiler backend. So how do we get them to talk to each other? Well, what we've done is take Clang, which is open source, and build a thin middle layer that takes Clang's output, which is LLVM formatted intermediary representation, and converts it into something that C2 can understand. So the compiler stack looks like Clang, and then our little middle layer, and then C2. And what you get out of that is a completely native UWP binary that is indistinguishable to the system from any other UWP app. So these are real native Windows apps that you're building that happen to use Objective-C, the language you already know. So a few weeks ago, we just shipped a community technology preview of our ARM32 compiler so that you can build those apps for Windows phones. We also support x86, so you can build for desktop and tablet. Now, the Objective-C runtime that we use is an open source project called libobjc2. And it's really great, and we're going to talk a bit more about how exactly that works later on. But what it allows us to do is give you a full complement of debugging features in Objective-C in Visual Studio. So that's the first piece. That's our Objective-C compiler and runtime. Now, the second piece are our iOS frameworks and tooling. Now, I mentioned the iOS APIs. And what we've done is built out large parts of those APIs on Windows. But it's not just the APIs. Because if you have an Xcode project, you've built your iOS app, you've got all this other stuff, too. You've got all these storyboards where you've meticulously laid out all of your transitions. And you've got zibs where you've laid out all of your controls. When you use the bridge to bring all of that stuff over to Windows, we will automatically generate a Visual Studio solution for you that doesn't just preserve all of your classes and all of your folder structure, but it converts all of those zibs and storyboards into Windows-compatible nibs. So even if you haven't laid out your UI programmatically, even if you've built it all using Xcode's interface builder, all of that will be preserved when you come over to Windows. Now, the third piece are our Visual Studio integration and tooling. Now, I'm not just talking about syntax highlighting here. although we have that in Visual Studio. It's a lot more than that, right? What I'm talking about is full XAML interoperability. That means you can access XAML controls directly from Objective-C. You can mix and match XAML controls with UIKit controls completely seamlessly, and they're all rendered by the same compositor and treated the same by the runtime. But it's not just UI stuff. I mentioned you get access from Objective-C to the full complement of UWP APIs. That means you can tap into live tiles directly from Objective-C. That means you can pop toast notifications. That means you can start taking user input through Cortana directly from Objective-C, right alongside all of your other iOS code. So think about that for a second, because this is really cool. As an Objective-C developer, you can take your app, quickly get it up and running on Windows, and then you have access to not just large parts of the iOS development world, but the entire Windows development world. You have all of that at your fingertips, using a language you already know, using tools you've already learned how to use. Now, the cool part about that is the bridge is a bolt-on SDK, so you can use as much or as little of any of this as you want to. If you want to swap out all your UIKit controls for XAML controls, you can do that. If you want to mix and match, you can do that. If you want to tie into Cortana, you can do that. So let's take a look at a real-world example of what this actually looks like. We've been working with a company called Game Insight. And now they are an iOS game developer, and they've got a number of apps on the store. But we've been working to explore different ways we could bring more of their games over to Windows. And the one we're going to take a look at today is called Mystery Manor. I'm just going to tap through a couple screens here and show you this. Now, this is all native iOS code, Objective-C code, running on Windows. And as I tap through, you'll see a lot of animations happening. Now, all of these animations are thanks to Core Animation, which is iOS's default native animation framework. Now, when I tap on any one of these items, you'll see a whole bunch of particle effects. That's all thanks to OpenGL, which we have full support for on Windows. Now, as I tap through, you'll see some of these panels here. And what you might not know from just looking at it is that these panels weren't actually built programmatically. They were actually laid out in ZIBs, in Xcode, using auto layout, using UIKit. Those are UI buttons and UI labels. And all of that was preserved when we brought this app over to Windows. Now, the other thing that you're not seeing here is all of the foundational work that went into getting the business logic of this app to run. Now, that's not just all of the logic from transitioning from one scene to another. That's things like core text, getting fonts to render properly. So all of that translates seamlessly for you as a developer. Now, this game was built using Cocos 2D. And if any of you have ever used Cocos 2D before, you might know that it's built on top of OpenGL. So what you're seeing here is actually UIKit, Cocos 2D, and OpenGL all running side by side, completely natively on UWP. So that's an example of what this looks like in the real world. So what have we just done? We've just shown you a 2D iOS game running on Windows. And I mentioned a few minutes before that we just shipped a community technology preview of our ARM32 compiler, so you can start building your apps for Windows phones. But if you were here last year, you might remember we got up here and we showed you Candy Crush, a 2D iOS game running on a Windows phone. So what have we been doing for the last year? Well, when we started this project, we had a very different set of goals from what we do now. The idea was to quickly get a small number of apps over to Windows with as little additional work for the developer as possible. And the way we did that was we took compiled IPAs, iOS app binaries, and we linked them to Windows binaries as foreign objects, as an asset. And what that meant was we had this divide. We had this divide between the C# world and the Objective-C world. And we had a custom bridge that would marshal calls and parameters over that divide. But what that meant was we had non-standard calling conventions. It meant that we had a really bad debugging experience because call stacks were really hard to reconstruct across that divide. And it meant that we had to have two separate compositors to render all of that UI. Now, there are workarounds for all of that stuff. I mean, we showed you Candy Crush last year. It works. But it gets uglier and uglier the further down that rabbit hole you go. And it's really hard to scale up as an SDK that we could distribute to developers. So before we open sourced last summer, we completely re-architected the project from the ground up. And to tell you a little more about how that architecture works, I'm going to call up my friend Dustin Howitt, who's a software engineer on the project.
Thank you, Nick. Is this thing on? All right. Hey, everyone. I'm Dustin, an engineer on the Bridge team, as Nick mentioned. And like a lot of you, I'm primarily an iOS developer. So I think this stuff's super exciting. Now, earlier, does this thing work? Earlier, we showed you our architecture diagram. And I wanted to highlight these blue boxes here, our Objective-C runtime, and what that affords us in terms of debugging support. Now, if you've been following us on GitHub, you may have noticed we recently switched to a new runtime, libObjective-C2. Now, libObjective-C2 it's an old project. It's got 20 years of history, but it's fully Objective-C 2.0 compatible. Now, switching is no small feat, so why would we do it? Well, I'll level with you. With our initial technical preview back in August, you came to us and you told us what you needed to bring your apps over, what we could do for you, and we listened. libObjective-C2 provides everything you need. You get native message dispatch. It's a tail call straight to the implementation. There's no overhead. You get automatic reference counting. Our compiler, our runtime, they insert the memory management calls so you don't have to. And you get the full host of reflection functions. You can write your crazy object models, inspect objects at runtime. It's all there. Now, all of this comes together to let you reuse more of your code. And once you've reused your code, maybe you're thinking you want to take advantage of some of the platform APIs that Nick was talking about. Toast, Cortana, LiveTiles. And I've got good news for you. So Objective-C is a strict superset of C, which means you can do this if you want. This is 24 lines of C++. It will pop up a Toast notification that says, hello, build. Now, I don't know about you, but I'm way more comfortable with Objective-C. And let's be totally honest, this is a lot of code. So what we've done is we've projected every WinRT API as a native Objective-C class with native Objective-C methods. So these 4 lines do the exact same thing. It's more concise, and you can interact with them just like you would any Objective-C objects from any Objective-C framework. Now, all right. You've written your app to take advantage of the platform. You're done, right? You can ship it. Well, unfortunately, Everyone knows you're going to have to debug sometime. And let's be honest, nobody wants to fix bugs. What we want to do is make that as seamless as possible. Because this doesn't tell you anything. What are those? Those are pointers. They could be strings. They could be anything. In reality, they're objects. So with Visual Studio 2015 Update 2, which was mentioned in the keynote, we've added native Objective-C support. You can look inside these. You can query their ivars, their properties, everything. But sometimes, let's be honest, this can be too much info. So name here, for example, name's probably going to be a string. But again, this is telling us a little too much. So we've also worked on native visualizers. We know the layouts of the objects so that you don't have to worry about it. And you get something more like this. Your arrays aren't just arbitrary buckets of pointers. They have meaning to you, not meaning to us. So our native visualizers take care of that. You know, I could talk about this stuff forever. Let's switch to a demo. So what I've written for you guys is possibly my favorite app. It's going to download an image from the internet and display it on the screen. Now, going to give it a run, and does anyone have any guesses? What's my favorite image? Yeah, you probably can't tell me. All right, well, it shouldn't have worked. All right, it worked great. That's not part of the script. OK, there's nothing to debug here when the app works properly. However, if the application's actually broken, say you get an exception, you can drop in and check this out. These are Objective-C objects. You can open them up. You can even evaluate functions against them. Call description, see what it prints out. You can open them up, look at their ivars. You can dig in as deep as you want. Now, back to the problem at hand. So what's going on here? We have CG image create, all right, and we're not getting an image back. And in fact, our exception handler caught that. So this looks a little suspect. Now, 4,096 bytes is a little too round for a PNG. But let's open it up. It looks all right. Now, all right, can't really see anything wrong here, but we know it's coming back from a server, so let's pop that open. And check this out. This dictionary, it's a set of keys, values, rendered as native strings. And we can see that the content length doesn't actually match what we're getting. That's 21,000. That's not 4K. Well, let's go back to where we are loading the data. And if you saw me fix the gaff earlier, you saw me delete the underscore because that was part of the demo. But it looks like we're actually trying to accumulate the data to itself. So if we rerun that with our fix, we'll get, spoiler alert, Ninja Cat riding the T-Rex, and a toast notification in the bottom right using the same 4 lines of code I showed you earlier. Now, just for fun, let's set a breakpoint here and stop and step in a little bit. So we open this up, and we see that it's got a COM object and an inner interface. With our projections, we've taken care of all of this stuff, so you don't have to worry about it. You don't need to do reference tracking. It's all natively translated through to Objective-C. Thank you. Now, toast notifications are great. Live tiles, Cortana, awesome. But say you want to take it a step further. Say you want to integrate your UI with XAML. So I'll digress a little bit. You might know that every UI view is backed with a core animation Quartz Core CA layer. A CA layer knows a lot. It knows how to composite itself, render to the screen. And XAML has a similar system. It's got panels. Every panel knows how to composite, how to render to the screen, how to parent other panels. Now, what we've done is we've taken CA layer and backed it with its own XAML panel. And let that sink in a moment. This means that you can take your XAML controls, a XAML date picker, a media element, and embed them in a UIKit hierarchy seamlessly. These are in a table view, in a navigation controller, and if you want, you can put them in another XAML element. It's pretty cool. All right. So we've seen a little bit about how a bridge app. Oh, I forgot about this guy. Well, all right. XAML and UIKit are both pretty opinionated, right? So XAML wants to be in control of the main thread. It's got its own event loop. And UIKit wants to be in control of the main thread as well. So how do we deal with that? Well, fortunately, they're both event-based. They both run on event queues. So what we've done is we've put XAML in control. And when it drains its events, it dispatches over to the NSRun loop. And when the NSRun loop drains its events and the UI queue is empty, it switches straight back over to the XAML fiber. Now, this means that wherever your events come from, wherever they're going, they get dispatched to the right place. And it just works. So, all right. Now we've seen a bit about how the platform works. And I'd like to hand it back to Nick to tie it all together for you. Thank you.
Thank you, Dustin. So, we've talked a little bit about what the bridge is. And Dustin showed you a little bit of how it works. But you're here today, you're an iOS developer. What does it do for you? Well, I want to reiterate this point, because this is really important. Bridge apps are UWP apps. These are completely native UWP app binaries. That means if you choose to distribute your app on the Windows Store, it sits there right alongside all of the other UWP apps. That means you don't just have access to the 270 million people running Windows 10 devices. You have access to whole new form factors. So if you've written an iPhone app with a certain form factor and a certain number of users in mind, all of a sudden, whole new classes of devices are open to you using the code you already know how to write. You can run that code on a Surface Book like this one, or on a Windows desktop, or on a Windows phone. All of that is available to you as an Objective-C developer. But it's not just that. You get to use Windows 10 features, like Live Tiles, like Cortana, like Maps, all from Objective-C. So bridge apps are UWP apps that use iOS tools. So you can maximize your reuse and minimize the amount of additional work that you need to do to get up and running. Your skills still apply on Windows. Now, we've talked a lot about frameworks. We've talked about UIKit and Core Foundation and Core Graphics and all these other things, all these other pieces of the iOS world that we've made available to you on Windows. And there are tons of these frameworks. Now, we have this saying on the team that it's a bridge, not a port. And we say that for two reasons. The first reason is that these aren't ported apps in the traditional sense. These are native UWP apps. There's no middleware layer. There's no virtualization or emulation going on. You get native performance. But the second reason is because iOS is really big, and there are a lot of those frameworks. And iOS is growing all the time with every new version that Apple releases. And the truth is, they put more people on it than we do. So it might seem a little bit like a fool's errand to try to catch up, because we'll never be able to cover the whole thing. But what we found is we don't actually have to. But instead, if we can collectively cover a critical mass of those APIs, along with our partners in the developer community, as well as our corporate partners, we can enable you to reuse the absolute maximum of your existing code while also building a great UWP experience that takes advantage of all UWP has to offer. So that's why we're open source. And if you've been following us on GitHub, you might have noticed that a few weeks ago, we added support for the Accelerate framework. And just last week, we added support for the Core Motion framework. so that your apps can respond to device motion, like rotation, on Windows devices. Now, all of that work was thanks to our partners at Intel. And to talk a little bit more about that work, I want to invite up Juan Rodriguez.
All right, thank you, Nick. All right, thanks, everyone. Can you hear me? Can you hear me well? OK, great. So my name is Juan Rodriguez. I have been working with Microsoft for over 20 years in the areas of developer tools, runtimes, system software, and performance. Now, Intel and Microsoft have a long history of collaborating together, driving technology initiatives for the benefit of our joint customers. And this is no exception. Our collaboration with Microsoft is broad and across many areas. And I'm very, very happy to be here today to represent the Intel team that has been collaborating and partnering with Microsoft and the opportunity that the bridge creates to help to bring your Objective-C skills, your Objective-C assets, over to develop great universal Windows platforms using Visual Studio. Now, this morning, I was kind of like blown away at more and more features of Visual Studio, the ability to do multi-device development, the ability to target different classes of applications. And I'm continuing to be blown away by the amount of functionality that the team collectively brings together, especially in this context. Now, what I would like to do is to tell you that, of course, as Intel, we have a robust inventory of Windows 32 applications, right? And it is our intent to ensure that we have a very robust and healthy application ecosystem on the Windows 10 platform, right? And as such, enabling scenarios where we can have UWPs, okay, to complement that story, are critical to the health of the Windows platform. So that's why we're here. That's why we believe and participate in this project. Now, I'll spend a couple of minutes to talk about some of the contributions that Nick already described that we have made to GitHub. And I'll talk about it in very general areas, general terms, just to give you an idea of the functionality that we've implemented. And I will invite you to go to GitHub and check those out after the session is over, okay, at your leisure. So the first contribution that we've made to the bridge is to implement a set of APIs for matrix and vector mathematics, digital signal processing, and functions for image manipulation, such as the ability to do convolution and matrix transforms, okay? The second set of contributions that we have made are to be able to read from an image source, such as a BMP, a bitmap, a PNG, a TIFF, a GIF, and icons, as well as the ability to create thumbnails. And the third contribution that we have made very recently, just as of last week, as Nick mentioned, is something that I would like to demo to you today. And to do that, I have my partner in crime, Han. Han's in our team as well, in the Windows OS team at Intel. And what we're showing you right here is an an application built with Objective-C and the bridge. And as you can see, Han is demonstrating this on a Surface Pro 4 running the latest Intel 6th generation core processor. And it is a relatively simple application. You see it is a 3D image of a cube responding to Han's movements of the device. And some of you can probably already tell, right, what it is that we're doing here, where we're talking to the sensors on the application. And in this case, we're interfacing with the Windows runtime APIs and the Windows device and sensors namespace. And in this case, we're responding to the accelerometer on the display, on the platform, excuse me. Okay? Simple functionality that you developers, we all developers, are used to having on the Windows platform. In this case, it's being reflected to you through Objective-C APIs in the context that you know how to develop it. Okay? Great. So where do we go from here? right? So as we look into implementing additional APIs and making performance optimizations to those APIs that we have already developed, okay, we will continue to work with Microsoft and the community in order to ensure that we implement those APIs that are the most high value for our customers. So as Nick described, right, earlier, this is a huge surface area to implement, right? We do not have to implement everything, right? We'd like to implement those APIs that are the most critical to help to get you guys to get those applications up and running on UWPs to be able to, leverage the platform capabilities, the UWP platform capabilities, and the capabilities of Windows 10. And I will invite you to stay tuned on GitHub for our future contributions in this space. So stay tuned there. So Nick, I want to thank you for inviting me upstage and for the partnership, and
thank you so
look
much.
forward to contributing.
We've been really lucky to have Intel. Intel has made some major contributions over the past few months. So thank you, Juan.
All right, thanks, Nick. Yeah.
So that's really cool. So if you have built an iOS app and you're responding to shake events, that'll work on UWP now using Objective-C code. So we've talked a lot about frameworks and APIs. We've talked about what we've built out and what our community has helped us build and what our partners have helped us build. But really, at the end of the day, this is all about apps, right? This is all about making really cool UWP experiences for your users. Now, we've also been really lucky over the last 6 months to have a great partner in a company called Algorithm. Now, Algorithm, you may have heard of them. They have their flagship DJ Pro app for iOS is an award-winning app. And to talk about the experience of bringing that over to Windows, I would like to invite up Federico and Michael.
Thanks a lot, Nick. We really appreciate it. As Nick said, I'm Michael. I'm with Algorithm, and our core and flagship product is DJ Pro. I'll tell you a little bit about our history so we can move forward and give you an idea of where we've been from, because you could absolutely call us Apple and iOS and Mac developers. The company was actually founded in 2006, where our initial product was called DJ. And DJ was seen as sort of a mission to take DJ applications, which at the time, think about it, 10 years ago, really didn't exist. In fact, they didn't. You had to get complex gear. You had to buy a lot of equipment. You had to lug it around. You had to have a lot of experience of analog turntables. It really was a very cumbersome but committed craft. Well, we released DJ 1.0 for Mac back in 2006, and our goal again was to make everyone a DJ, give them the tools, the ability, but more importantly, the functionality to just take your audio files right from iTunes, start mixing. And we really were very successful with this product, we're proud to say, because we went on to release it for iPad and iPhone and Apple Watch and Android, and we actually are now the top-selling music app with over 20 million downloads. But more importantly, if you go to our website and look at our ambassador page and our user page and the inspiration page, the amount of people that are just DJing that would never have been able to DJ before and have stories to tell are very inspiring to us and make us feel really good. Well, part of this mission, of course, Apple Design Awards, Google Editor's Choice Awards, even getting Apple Editor's Choice for all of the platforms, which is unprecedented, is great. But in a company like ours, you might ask, why Windows and why now? Well, actually, Windows has been something that we've wanted to do for a very long time. It's our #1 user request. It's also a very big market, as we all know very well. But for our company, because we had so much experience, 10+ years, and all of our engineers were very capable Apple developers, coding in Objective-C and all the frameworks of Apple, as you can imagine, with over half a million lines of Objective-C code, it wasn't going to be a very easy task. And it was one of those tasks that every time we looked at it, we were very interested, and then we kind of, all right, maybe next year, or we'd look at this solution or that solution. It really was a thing we wanted to do, but really was a lot of work and a big challenge. But it really was the missing piece to our let everyone be a DJ. Well, as we know, as we're here today, and what we've heard from Nick and the rest of the crew, is that there's been a lot of advances, not only in Windows 10 graphics and audio technologies, but we now have the iOS bridge. And the iOS bridge is going to allow us, developers like you, to take all of the code, all the experience, all of the knowledge you have from the Apple platform and port it over. And if it seems like I'm excited, I am. We've really had a breakthrough working with the team in the sense of being able to port over to Windows 10. And one of the things that makes us really excited is obviously on the Windows hardware ecosystem, you have things like the Surface Book where you can touch, have keyboard, it's the best of both worlds. So it's really exciting to kind of have this final piece of the puzzle be on a hardware device that's so capable. So a lot of questions that I'm sure you're going to probably have is why the iOS bridge and what is it about and how did it inspire us and get us to do things even better? Well, as I mentioned to you, we develop with the core technologies of iOS and OS X, Cocoa Touch, OpenGL, Cocoa, et cetera, Objective-C. And I'm not exaggerating when I say we have over 500,000 lines of Objective-C code, and our app is really, really big. How many of you have used DJ or heard of DJ or seen DJ, just by a quick show of hands? All right, so a few. That's good. Well, with all of our engineering and all of our experience and all of our years being in business coding, we have all this code and all of this stuff that needs to be dealt with. Well, now with the iOS bridge, we can actually reuse all of the code that we've developed. We can actually take what we've built and rather than worry about it, actually bring it to Windows. It allows us to maintain a cross-platform code base, which now, as I mentioned to you earlier, we have Mac, iPhone, iPad, Apple Watch, Android, and now Windows. We have one code base that we have to maintain. We have feature parity across all platforms, touch, and so on. And of course, it allows for faster development cycles now, because now that we've done the bridge, we're there. So rather than talk a little bit more about DJ Pro, I'm going to actually show you a video that demos the best features of it. And we'll switch in a sec. Wrong. Nope. OK, thanks. The Windows bridge is not password protected, I swear. We've done a lot of development with it. Yes? All right, so let's go ahead and get into that demo. Or video. So what do you think? Woo! Thank you very much. So with that, I'm going to turn it over to my colleague and one of the co-founders of Algorithm, Federico.
Thanks, Michael. Thank you. Now let me share with you some experiences and challenges we have had using iOS Bridge. We, as Mac iOS developers, use Xcode every day and found Visual Studio to be easy to get around in and quite refreshing. The iOS Bridge team has done a tremendous job integrating iOS Bridge into Visual Studio. If you have an existing Xcode project, a command line tool called VS Importer will convert your whole project into a Visual Studio project with all your classes and settings. Now, if you have a blank project or an existing Visual Studio project, adding a simple build customization file will do. Additionally, you would want to run the Objective-C syntax highlighting script included in iOS Bridge to enable Objective-C syntax highlighting in Visual Studio. We found that the debugger works perfectly, and it allows you to set breakpoints in your Objective-C methods. And as Nick said, it will allow you also to inspect your objects. So we recompiled and run our initial prototype on Windows in less than 2 weeks. But iOS Bridge is in beta, and thus not everything works out of the box. So for example, key value observing at the beginning, it was missing, but it was then soon added by the iOS Bridge team. AF networking did not compile due to various missing APIs. Version 2 now works. NS predicate was missing, so we had to hack around using other APIs. And there were a lot of small bugs in the APIs, a lot of which we could fix ourselves. One thing that was very helpful is the fact that iOS Bridge turned open source. It was tremendously helpful for our engineering team. It allowed us to dive into the code, add missing APIs, and fix issues ourselves. Over the past 7 months, we sent feature requests, we sent bug reports, and we fixed 11 issues ourselves via pull requests. It was great seeing these pull requests being picked up and merged right into the master branch by the iOS Bridge team within days. So let me share with you some of our code contributions and drink some water. Oh, there we go. Now, there we go. So for example, for NS value, there was an issue with wrapping, unwrapping when using key value coding. Then we had an issue with NS invocation when you had a method returning a double value. We also implemented from NS condition log the try log method. And for NS property list serialization, there was an API that was not being exported in Foundation DLL, so we also fixed that. One thing to keep in mind, though, is that for NS predicate, it was missing. And so there are going to be other APIs missing. So for us, we had to hack around some APIs to get our code to run. For example, NS value transformer, we had to write our own implementation just to get our code to run. For NS cache, we wrote a super basic implementation of a cache that it is not much of a cache, but more of a wrapper around an mutable dictionary for now. And sometimes an API that you're using is missing, but an older API is available. So for the case of NS property list serialization, what we did is we added a category on the class implementing the missing API that was based on the older API. There we go. Now, let me share with you how we maintain this cross-platform code base. As much as you want to encapsulate OS-specific code, sometimes a good old if-def will do. One thing to keep in mind, though, is if you have a cross-platform Mac iOS code base, is that iOS Bridge is an implementation of the iOS APIs. So if you're checking already for things like Target OS iPhone, you might want to check also for the Windows build. For this, we added a preprocessor macro called Target OS WinObjective-C, that's how we called it, to denote the Windows build using iOS Bridge. So let me show you how we use this in code. So for example, if you're using OpenGL, a lot of the methods are going to be the same on Mac, on iOS, and iOS Bridge, but the header includes will differ. So it would look something like this. If you are using a timer, the run loops on iOS and iOS Bridge are going to be the same, but they're going to be different on the Mac. So it will look something like this. If you want a random number, arc4 rand uniform is not available on iOS Bridge, so you may want to fall back to rand and do something like this. And opening a website is you can just call OpenURL on UI application like this. Now let me get back to Michael, and he will share with you some of our best practices using iOS Bridge.
Thanks, Federico. So before we wrap up with our part of the presentation, we wanted to just share with you a few of the best practices that we ran into. If you do a little digging on Algorithm, you'll see we're one of the kind of more hardcore Apple developers, if you will. because of our graphics, because of our audio, because of all the things we're doing. So we had all of this rich experience to work with and create and bring feedback to the Microsoft team, and they did a great job. And I kind of want to share with you some of these best practices that can help you when you dive in. So it might seem simple, but get your code to compile first. As I mentioned, we had over 500,000 lines of code, and it took us only about 2 weeks. And what's funny is we kind of say only about 2 weeks. Obviously, we didn't know what it would be when we started, but 2 weeks is pretty impressive for a project that's almost 10 years old, or is 10 years old, and has over 500,000 lines of code. But once you get your code to compile, now you've gotten everything out of the way that could be a hurdle, and now you can start going. Another thing is to encapsulate your OS-specific code using design patterns. Really good tip that'll help you. The third best practice actually is kind of a funny one. You want to test performance on an actual Windows device. In the beginning, we used VMware, and obviously having a virtual machine is great and convenient, but we were running into a lot of really weird audio issues or visual issues, excuse me, and once we switched over to an actual hardware device, they went away. So we know that we all know there's idiosyncrasies with VMs, so I strongly recommend you're going to do this, get hardware, and make sure you're actually testing on hardware. Another good tip and best practice that I would recommend highly from the team is to call native Windows 10 APIs using Islandwood's UWP bridge. That's really going to help you a lot in your development. And update frequently. Every week, basically, sometimes more frequently, there are updates. So you should always be on the latest and greatest to make sure not only you get the best fixes, but that you're also developing with the latest stuff and you can test against it and make sure that it runs appropriately. And of course, stay up with GitHub commits and do a lot of pull requests, and the team will be responsive. What I can tell you in looking at certain things is, if you're waiting for something to happen, it probably won't. So be interactive and actually make a difference. And the only other thing I guess I'd say is we were so inspired by doing this that we kind of hope and we look forward to seeing what you as iOS developers can do with Windows Bridge for iOS. Thank you. Oh, wait, and there's one more thing. So we're announcing this first, and we hope you'll be excited. And we are the most excited because this really completes the picture that we've had for over 10 years. Coming in June, DJ Pro to Windows 10. Now thank you. Woo.
All right, thank you, Michael and Federico. And I just want to reiterate, Algorithm has just been a really great partner for us. And they're such a great example of what's possible using the bridge. Right? They were leveraging all of these core technologies of OS 10 and iOS, and they were able to reuse all of those 10 years of development, that 10 years of code and experience that they had to build a really awesome UWP experience. So you're here today, you're an iOS developer, you can get started right now. The bridge is up on GitHub, you can go download it, and if you do, and if you want to get involved, submit a pull request, file an issue. It's really the best way to get in touch with our team. We're always on there, and it really actively guides our own development. But if you're an iOS developer, you might not have a Windows box. So we've actually also created evaluation virtual machines that you can download from our website that are pre-configured for your virtualization environment of choice, whether that's Parallels or VMware. And while a Windows 10 machine really is the best way to do this, it's a quick way to get up and running with the bridge. And it also means that on one computer, you can run Xcode and Visual Studio side by side using a shared code base. So you can maintain one folder with all of your code in it and have iOS-specific parts and Windows-specific parts, and that'll all translate completely seamlessly, and you can compile that natively for iOS on one side and for Windows 10 on the other side. So these VMs are pre-built with Windows 10, Visual Studio, and the bridge. It's really easy to get up and running. So I want to open this up for questions. We've only got a few minutes left. But before I do, there's one in particular that I know I'm going to get, so I want to address it right now. What about Swift? So Apple has made it really clear that Swift is the future of iOS development. So clearly it's key to our project. All of the sessions last year at WWDC were in Swift, and Apple open sourced Swift in December. They've made it clear where they're going. But the thing about Swift is it's still changing a lot. They haven't guaranteed ABI resiliency. So if you write a class and it's expecting to talk to another class in a certain way, that might break with a future version of Swift. And they haven't guaranteed language stability. Supposedly those things are coming later this year with version 3.0. So we're working on it, and we will bring Swift to Windows. It is the future of this project. Thank you. But in the meantime, there's a ton of Objective-C code out there, and there are a ton of Objective-C developers like you out there. And we really want to take all of those skills that you have and all that code that you have and put them to work building UWP apps. So with that said, thank you guys so much for coming. We're really glad that you guys came. And can I invite Federico and Michael and Dustin and Juan back up here, and we'll open this up for questions. Thank you guys.